Yeah, so for around 30 years I've been studying the aging brain, and I've looked at it from all different perspectives. But over the last 15 years I've been interested in how our brains age in terms of our higher level cognitive abilities, and specifically how interference degrades those abilities. By interference I mean distraction from irrelevant information. That's information we choose to ignore, and multitasking. So when we choose to engage in more than one information stream at a time. What we found is that as we age, our ability to manage both of these types of interference declines. So on the distraction side, our filter that we apply to block out information that's irrelevant to our goals is not as effective, and that information gets in and degrades the relevant information, whether you're trying to hold it in mind or make a perceptual decision about it. On the multitasking side, we find that the networks that are engaged when you switch from one task to another, even if you're trying to multitask, we know that you effectively move between networks as opposed to parallel process them. It seems that that network re-engagement when you move between tasks when you're older is less effective, and that also degrades performance when you're multitasking. So to sort of summarize that, what we found is that although everyone is subject to interference effects through distraction and multitasking, degrading their performance, both of these forms of interference become more detrimental to your performance across a wide variety of domains as you get older. Yeah, so what the general literature suggests, if you view it across many different clinical populations, is that if you pretty much have anything that affects your brain, whether it's dementia caused by the many diseases and conditions that do, or any developmental challenge, as well as things like traumatic brain injury, post-traumatic stress disorder, depression, the list is long. Basically, if something affects your brain and degrades cognition, the data suggests that you are more susceptible to interference in general. You're more distractible, you're going to have a harder time dealing with multiple streams of information. Yeah, there was a convergence of things back in 2008 that interested me and made me sort of take this leap to video games as a therapeutic tool. I mean, the first is that I was motivated to work on new types of interventions to improve cognition because as a neurologist, I find that the way that we treat, which is largely dependent upon small molecules, pharmaceuticals, are not very effective for the things in our world. And that's true for psychiatry as well. And so I was excited to pursue a new approach and see if we can improve the variabilities that we find decline with aging, as we just discussed, interference processing, but the larger scope of cognition as well. And so I was trying to find what would be an interesting and a novel area for me to investigate. And I was inspired by a couple things. First, being here in San Francisco, knowing so many people that meditate and do other forms of sort of self-treatment and therapies, really sort of opened my eyes to this idea of what I've come to think of as experiential treatments or experiential medicine. The idea that you can engage in a certain practice that doesn't involve ingesting something that challenges you, that harnesses your plasticity, which you referred to, and can act to improve our function. And these are ancient practices like mindfulness and meditation. So that was one thing that was interesting to me. But I saw many limitations in those fields, like the need usually to have a high-level teacher and the accessibility issue that may be around here in the Bay Area. There's lots of meditation classes and retreat centers, but it's not everywhere, and it's not necessarily completely affordable for everyone. And it's also not the same type of interactivity that everyone enjoys or finds something that's amenable to their lives. There was another literature that seems very different but also attracted my attention, and that was research showing that commercial video games, so video games that are designed really for entertainment purposes, have been shown in careful research studies to improve cognition, especially the research on first-person shooters, very sort of immersive action video games, and their ability to improve cognitive control, attention and working memory and resistance of distraction, the very things that I study, especially in younger adults who tend to play them. And so I was looking at these two worlds that seem very different, ancient meditation practices and video games, and realizing that they're probably both having benefits because of their applied pressure that they're placing on different cognitive systems through very different types of interactivity. And I was interested essentially in sort of combining these ideas. Could we design video games from scratch that may be putting pressure on different systems than they standardly do in entertainment games, but take advantage of the fact that technology can be used to deliver very accessible experiences because we all have phones and tablets on us and Wi-Fi connectivity. The other thing that I was very intrigued about that hadn't really been done to the level that we are doing it now is using the technology platform to capture information about an individual while they're interacting with the media, and using that data in a closed-loop fashion to update the challenges and the rewards in a personalized way. That's something that real-world experiential treatments like meditation, for example, suffer from, that you are really not getting a personalized treatment. And even video games, which are updating levels to some degree, are not doing so in a very rapid fashion. And so to conclude, the idea is to use a video game as a platform to deliver an interactive experience where the mechanics of the gameplay are activating networks in a selective way in a manner that we've never achieved with a molecule before. And then the closed-loop system, which is adapting the challenge and the rewards in an appropriate way to you in real time based upon data, applies pressure to those systems. So the brain's own inherent plasticity optimizes its abilities. So that was the general idea 10 years ago of why a video game was interesting to us to custom build for this purpose. Sure. So the first video game that I built with the premise that I just described was called Neuro Racer, and that was designed originally by me but developed with friends of mine in the video game industry at LucasArts. It took us a year to build that game with the hypothesis that by challenging interference resolution, distraction resistance, multitasking, because it's so fundamental, those networks, to other cognitive control abilities, we would see benefits outside of gameplay and different abilities that were not directly challenged. And so we did a multi-year study in older adults and showed that we improved not just their gameplay, but their sustained attention and their working memory. And showed with neural recordings that it was the engagement of the prefrontal cortex and its networks with the rest of the brain that were more effectively improving those abilities in older adults after training compared to control groups. And so that was our first big study in this domain with a custom designed video game. We published that in Nature in 2013. And then in parallel to that process, I created intellectual property around the method behind the game, what we think of as the game engine, that's owned by my university, UCSF, and used that to seed a company called Achille Interactive, which licenses that technology and now has created a much better game that went by the name of Project Evo. It's still changing its name for its final release. And that game preserves the basic methodology that was in Neuro Racer, but brings on much higher levels of art, music, story, reward cycles, usability, very complicated game dynamics that lead for a much more enjoyable, engaging experience. And also much more sophisticated challenges across multiple domains than was ever accomplished in Neuro Racer. And that game has now been through multiple clinical trials and still continues to be tested, including a phase 3 study that's a prospectively designed, multi-site, double-blind, randomized, placebo-controlled trial in children with ADHD. Which effectively reached the primary outcome measure, an improvement of sustained attention that was pre-submitted to the FDA. So everything was really buttoned up in a really very nice methodological approach. And that is now positioned to the FDA as approval as a Class 2 medical device to treat attention deficits in children with ADHD. So we're working through that, but we hope that not in the distant future. It's a slow process. It's a de novo pathway, but we hope that this will become a new treatment that will be prescribable and essentially the first prescribable video game and non-drug digital treatment for ADHD. I tend to think of cognitive control as an umbrella term. That term falls into other categories like executive functions, and which I think are even a bigger term. But cognitive control, how I define it, and I define it. I have a book called The Distracted Mind, and for almost several chapters, I break it down because I think it's really critical to understand both the negative impact of technology as well as the opportunity of technology, because a lot of it focuses on cognitive control. So cognitive control is essentially the abilities that enable you to enact your goals. So you have a goal to accomplish something, which is another whole set of abilities of how you even form goals in the first place. And then you need to carry it out. And so what you need to do is to control where your limited resources are. So I put under the umbrella of cognitive control attention, both selective attention, which requires focus and filtering, as well as sustaining that ability, that attention. And then moving the attention when you want to. So that could fall into subcategories of multitasking and task switching, or cognitive flexibility, goal management. It goes under many different names, but essentially holding attention, moving attention, and then directing attention internally to hold information in mind, which is what we call working memory. So they're all basically the same concept. Is you have a goal, you have limited resources of focus. How do you hold it, move it, direct it in order to accomplish your goals? And all of that we think of as cognitive control. I mean, it's not very easy to have closed loop systems in the real world. There's some degree of that occurs. We create those systems semi-naturally, like having a trainer. I mean, that's what a trainer is doing. Let's say a physical fitness trainer is standing with you in an exercise gym, looking at how you're working out, how much weight you're using, how much effort it's taking, how much you used yesterday, saying go up a little bit. They're trying to essentially dynamically adjust your workout based upon your abilities and your goals. That's exactly what we do with digital technology, except we do it way more accurately because we're getting much more data and way more rapidly, because that's what our algorithms are designed to do. But in the real world, the world often moves out of your way when you push on it. It doesn't push back with an equal force. And in the real world, we tend to often try to achieve the lowest possible energy, unfortunately. So like for an example I use, because I remember using this example when asked questions after talks many years ago when we first presented Neuro Racer. And Neuro Racer looks like a driving game. And so people would be like, why would I do that when I drive all the time? And it's a good way of talking about the closed loop, because in Neuro Racer, when you get better at managing the multiple tasks, like keeping your car on the road and responding to signs, as effectively and rapidly and selectively as you can, they both get a little harder. But like the route that I take to my office is pretty challenging. But when I get better at it, I don't find a harder route. And it doesn't respond by getting harder. It's just easier, which I'm pretty glad about. And so that's an example of what makes the closed loop systems different than the real world. That it's really constantly keeping you right on that edge of challenge in a way that you don't often find in natural systems. I mean, we're still working on understanding that. I think we made a lot of good decisions along the way. We've now done it several times. We just had a paper out on a meditation-inspired video game called MetaTrain that was in Nature Human Behavior just last week, delivered on a tablet, where we also showed transfer, pretty remarkable transfer, even beyond, in some ways, I think, what we show with Neuro Racer. So there are certain elements that we think are very important. The adaptive closed-loop nature is a big plus. We tend to build our games to create deep engagement, immersion, good feedback, and reward cycles. If you don't put pressure on the system, it's not going to change. You're not going to really get benefits, especially benefits that transfer. So I think a lot of approaches are just not that fun, and I think fun is really important here. And especially when you're dealing with young people that have sort of a high bar of what they feel like entertainment should be. And especially when you're asking them to do something multiple days and when you're asking them to do it deeply and really push. So I think that's another asset that we have. We have actually a paper in Neuron showing that the adaptivity is sort of like a scalpel, like determines what actual abilities are improved. So these are things that are like our core, that are true for all of our interventions, and I think that we do a pretty good job at developing them at a high level. And so I give part of the credit to that. The other part is knowing what abilities to target. So we tend to focus on cognitive control. Pretty much all of our interventions are on attentional systems. And attention's, a pretty good bet if you're looking for things to transfer, because we rely upon it for everything we do. If you have, impaired attention, everything suffers, everything. And you see that, and many studies have shown that, not just other cognitive abilities that rely upon focused and sustained attention, but real life activities as well. So we like that because we think those type of things have the best opportunity to transfer. And also many clinical conditions, as we've discussed, have deficits in those abilities. So again, that could lead to transfer to different clinical conditions with the same intervention. The other thing is we base a lot of our decisions upon what to focus on in terms of our mechanics, based upon years of cognitive neuroscience research, looking for networks that overlap across different conditions. That's exactly what led to Neuro Racer, is finding for many years that cognitive control systems share networks in common, so that transfer is not a magic trick. There has to be an underlying neural bridge between these abilities to allow you to get better at one after training in another. So I feel like our experience in cognitive neuroscience has been an asset in determining what we want to focus on. And then the other part of it is experimental design. It's not just what you build, it's how you test it. So it's really easy to pick bad outcome measures that are just impossible to transfer because there's no connection between what you are treating and what you're trying to improve, so it's a waste. Some outcome measures are quite appropriate, but they're not very good tests. In other words, they change dramatically no matter what you do. Even practice effects are massive. And so you're never going to find, even if you had a meaningful change, your control group's going to show a massive change too, and you're going to miss it. And so we spend an exhaustive amount of time on our outcome measures as well. And then other aspects of experimental design. How do you motivate your participants to really engage deeply? These are all the subtleties and the details that go into both the technology development side and the experimental design. I think one of the things that make us pretty unique is that we do both. We do tech development, and we develop that technology with an idea of what we want to transfer from the very beginning, and then we design the studies around what we've built. So there's no disconnect for us. It's just one system. And I think groups that may rely on other people's technology that they might not fully understand and have control over is a disadvantage when you're looking for these outcomes. So, I mean, it's a lot there, but it takes us a couple years to build every single game that we create, and a couple years to do our first studies on them. So, like our MetaTrain paper that we just published was 5 years from the beginning of that idea until our publication. So they're massive efforts on a single goal of creating these transfer effects and getting some evidence of sustainability. Well, it's complicated, and I don't pretend to be an expert on it, on the history of basically our education system is really what we're talking about. But, a lot from my reading, a lot of the didactic structure of education that we rely on globally really emerged from an Industrial Revolution period, where there was a need for people to learn a lot of facts, a lot more than they had before, so that they could work in a system that was becoming more information-based, and even a factory system requiring a lot of knowledge. And that education system and that content delivery that had to occur became our dominant form of what we think of as education. And it's not a bad system. There's a lot that does need to be learned. But I feel that the focus on the underlying information processing systems themselves and optimizing those just been deprioritized. And knowing, not just improving them, but even assessing them, right? Like understanding how a healthy 12-year-old's attention abilities are, how they selectively focus, how they sustain, how they hold information in mind, how they regulate their emotion, their degree of empathy or compassion. These are just not really evaluated. And so we don't even have the basis to then try to improve and optimize them. Unless we think there's like a learning disability or some type of developmental challenge, and then they fall more into the clinical scenario. So I feel like it's been a disservice that our education system, and even the term education, really most people will directly connect with learning facts, learning things. Maybe now learning skills is part of it too, but I'm not even talking about that. I'm just talking about improving how your brain functions as an information processing system. That is something that has not really been formally or traditionally part of what we think of as education. And I think a lot of it is historical. These are big, giant, behemoth institutions that are hard to move when they're already on a path. And you know, we've perpetuated a lot of them for our, you know, such that now we're, I think, feeling the consequences of it. Yeah, so that was, so over the years, I've become very interested in motivating the closed loop algorithms that we design for our experiential treatments, using principles from real world practices that have a lot of evidence, but have maybe suffered a little bit in some of the randomized control trials that, you know, professionals and regulatory agencies really look for that highest bar. And there's lots of reasons why it's hard in many ways to do those studies on those real world practices, to control them as much as you need to. And so things like meditation and mindfulness, physical fitness, rhythm and music were all things that were very interesting to me. And we've developed games around all of those now, and they're all in various phases of study. The meditation one was designed with collaboration from a thought leader in the mindfulness space, Jack Kornfield, who's a really dear friend of mine. We've been working on this for over 5 years, and what we designed was a closed loop system that allows you to have more or less time for focused attention to your breath. So using pretty classic focused attention instructions like done in Vipassana, where you focus on your breath, you keep an awareness of where your mind is, you try to hold your focus there. If it deviates, you acknowledge that, you recognize that, and then you return without judgment your attention to your breath. Doing that practice in the real world scenario usually requires really long periods of time where you don't know how you're doing, and it's really hard for a lot of people. The sort of insight that we had with MetaTrain was to start with just 10 seconds of doing that. And then as you introspect your own focus, that you are able to do it, you get more or less time. So that's the closed loop. So the driving data into the closed loop is your own introspection on where your attention is and how successfully you maintained it towards your breath. And then based upon that feedback, you get more or less time. And so most people that are naive to meditation in a 30-minute session on day one just average around 10 or 15 seconds. So they might go up, they go back down, and that's where they wind up. After 6 weeks, 5 days a week of MetaTrain, almost everyone's over 2 minutes, and some people are even 5 or 6 minutes. That's the duration that they're able to hold without distraction, which is cool and interesting. But what is more important and really what's most gratifying after, you know, the years of doing this study and the tech development is that other abilities of attention that are quantified very carefully in outcome measures before and after and pitted against a placebo control arm show improvement in attention and even working memory. This is in healthy 20-year-olds in our Nature Human Behavior paper. We have another paper that's in review right now of children, actually adolescents in India, who have suffered adverse life events and have attention deficits, also showing exactly the same benefits. So replicating that finding in a different population and extending it to behavioral benefits even a year later. That paper's not published yet. So we know what's in store for the world to see, so we're really excited about it. We're very happy with the paper we just published, but we know a lot more is coming, and we've completed a study of older adults that we're analyzing now as well. So to me, it's an example of how we really just harnessed a practice that's thousands of years old, but put it in a format that's really accessible, especially to young people who are very tech focused, in a way that allows them to have access to this ancient technology in a modern delivery format and shows quantitatively improvements in their attention abilities. Well, I'd say that when you're in the later periods, like week 5 and 6 of doing it, and you're holding your attention for minutes, it's pretty similar in my experience, because I've done a 10-day Vipassana retreat now with no technology at all, so I've seen the other side. It gets more and more similar as you get better at it, because you're not interrupted as frequently. I also think it's like a good gateway to real-world practice of meditation, because then you're like, over the 5 weeks, not only are you able to hold your attention longer to your breath, but you're able to understand your internal space better. That might be one of the most interesting and unexpected benefits from my perspective, is that this constant need to assess yourself of whether or not your attention was focused to your breath or moved is one of the benefits, is that you get to know where your attention is a lot better. So that was unexpected. I was thinking that the benefit was really just to be able to focus your attention, but what I realized through my own experience was that another benefit is being able to know where your attention is too, not just to control it. And then when you do the real practice of meditation, like at a retreat center, those are skills that you use there. So they're really one and the same. It's just like a sort of different implementation of it. But there's many, many different types of meditation, right? There's a sort of an open awareness meditation, there's loving kindness, and now we're looking to use similar algorithms to what we do at Metatrain and build different versions of it. We're actually now looking at one focused more on empathy and compassion, along with working with Jack on that. So that's pretty exciting to see us take this leap to other, sort of versions or other types of meditation and try to accomplish some of the same goals. Yeah, so there's lots of ways of looking at our ancient minds in the context of our technology world. I won't go through them all now. I mean, it took a whole book to break it apart, but some of them are, like, for example, our tendency to be distracted by bottom-up information, by stimulus information. That's a very ancient part of our brain. As a matter of fact, our attention is driven through these two forces. One is goals, we call that top-down. The other is bottom-up, by the sensory world itself. That was the more ancient approach. That was the more ancient driving force of attention, right? The bottom-up influence on attention is what basically allowed us to survive. It allowed us to seek out nutrients and to avoid toxins. So even at our very earliest stages, we were driven by the stimuli of the world to either move towards or away, which eventually became this attentional system. We're still very susceptible to that. It's not gone. It's an ancient part of our brain, but it's still there. It's still important for our survival, but it's the same exact aspect of attention that's often used by technology companies to pull our attention towards devices, buzzes, and vibrations, and flashing lights, and notifications. So that's an example of an ancient part of our brain that is challenged by the technology world, and probably by design. Another is that we have very fundamental limitations in our cognitive control abilities. We can't distribute our attention broadly very well. We have to focus. We take in a very limited amount of information. We can't hold an infinite amount of information in mind. Our working memory has very limited capacity. We can't simultaneously stream multiple sources of information, right? We know that you have to move between them. And so these are ancient limitations. They've always been there. You see them in other animals, and these are the types of limitations that technology uniquely challenges, because it's, you know, presenting us with lots of information source and incredible accessibility. So again, an ancient aspect of our brain that is challenged by technology. I think the third that I would mention is, you know, this is more of a hypothesis. It's presented in the book through optimal foraging theories. One particular one known as the marginal value theorem, which I really latched onto as an idea I was excited about, and Larry was willing to work through it with me, and we wound up presenting it, hopefully in a way that's at least provocative to people. And that's the idea of why we would multitask in the first place, especially in the second place when we know it is negative for our performance. And I think that a lot of the driving forces are some very ancient driving forces that sort of encouraged our ancestors, or drove our ancestors, our ancient ancestors, to forage for food for survival. That we essentially forage for information as well, and that our reward system has really been optimized for information itself, not just for survival purposes. And so we're often pulled in directions that we may consciously have reached a decision that are not healthy for us, but yet we're still pulled to engage in them in a certain way. And so these are the pressures that I believe create the negative aspects of how technology impacts us. I mean, it's essentially everything we do. You know, I feel like I've told the distracted mind story. I did a lot of research on it for a long time. I actually wrote a piece recently that the audience might find interesting called The Cognition Crisis, which is sort of more recent views that I have on it, a more global view from my travels and different perspectives. But for the most part, this is not a story I like to tell all the time. I'm more interested in doing things to help people. And I'm really fascinated by the idea of flipping the story around, of using technology designed from its very beginning to help elevate our minds and not diminish us. And so that's what we do at Neuroscape. That's what Achille does. Jazz is a venture fund that I'm a co-founder on. We invest in companies that do that. It's pretty much everything I do is to think about technology as a source of enhancing what makes us human. Yeah, so you know, to me it comes down to taking control over it, which is not easy because of all these strong, evolutionarily ancient driving forces that pull us towards some behaviors that we may consciously have decided are not good for us. But it does start with awareness of what our fragilities are, what our limitations of our mind are, that we can't do everything at the same time, that we are susceptible to being drawn to these very sort of simple bottom-up influences. So awareness is the beginning, but it's not enough. Behavioral change is super complicated. I'm not actually an expert in behavioral change, but from my own practice, you know, what I think that we're really trying to do is form new habits that then don't require that high degree of effort all the time, that become more effortless. And so building habits around a healthy interaction with technology involves first being aware of where the negative touch points are, and then starting the training process of restructuring your life so that your relationship is healthier. So for me, it comes down to realizing that sometimes multitasking is awesome and perfect for what my goals are. It's fun. I feel like it's a great way to do things that are low level, but you would not want to do them alone. They're just too boring. And so I'll like put times aside where I'll just multitask like crazy because it's super fun. I'll play music. I'll be jumping from here to here. Whatever pulls me is fair game. But I wouldn't like flip over to writing an article that's very important, that takes a high degree of attention and sustained attention over time. So I'll set aside different times, even on my calendar, for single tasking, and say this is where I quit social media, put my phone to airplane mode, close my door, and focus. And anything that's time sensitive, that has a high quality signature required for it, I will start doing that for. And now I could do it for an hour, no problem, but that's because for a year, over a year now, 2 years, I've been baby stepping with like smaller periods of time doing that, and then giving myself breaks. Like, so maybe 5 minutes, take a break, but that break is not social media. That break is maybe, you know, quiet, focused meditation, or some push-ups, do some physical exercise, or looking at nature right here out my window, and then getting right back in 30 seconds later. And all the time having the goal to go for a full hour of focused attention, sort of like training for a marathon. Like, you don't just run 20 miles, you know, you run a smaller amount and you build it up. So, you know, I don't consider myself a self-help expert. I'm only saying what I do for my own challenges with technology, which I have as much as everyone. I love technology, probably more than most people. So this approach that I've taken, I feel, has allowed me to interact with it in a healthier manner.